The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
All right, Juan. So I feel like every time we're on this podcast or we do this podcast, we talk about, these sit-down restaurants that we go to or these foods that we make at home. But the reality is that a lot of the people listening are more likely than not in a van, and they don't have time to do all these things when they're listening.
I mean, they're only getting 30 minutes if they're lucky. For lunch.
Yep. So what I was thinking we could talk about is maybe when you were in a van, what was your quick stop, go to either fast food or some sort of drive-through where you were, in a rush and you had to grab something quick. What was your go-to spots?
Well, Bryn, back in my days, you're asking me to take the clock way back. My go-to was Burger King back then. Now, today is a little bit different, but back then when I was in the truck, it was Burger King.
Okay.
And what I would order would be a double Whopper with cheese, heavy all.
Heavy all.
Yeah, heavy ketchup, heavy mustard, heavy pickles, heavy everything.
Yeah.
And most of the times I would get all that stuff on me as I was driving to the call. But Burger King, the onion rings, I love their onion rings, as bad as they are for you.
Yeah.
But I love their onion rings. So my definite go-to drive-through restaurant back then was Burger King. Today it's Chick-fil-A. But again, back in the day, Chick-fil-A was not out of a mall area.
Yeah.
So.
Yeah, I know I used to stop at McDonald's quite a bit because there was two in my town. So depending on what side of town I was working on, there was always a McDonald's, and my order was just two McDoubles. And so I eat my burgers a little weird. I'm sure you've seen me when we do sit-down restaurants, I don't eat the buns.
I know.
So when I go to a fast food place, it's like a whole operation where I get the two McDoubles and then I take the bun off of one of them, the bottom bun off of another one. So it's one bun, top bun, 4 patties, and I just eat it like that.
Oh, that is neat.
Yeah, it's weird. It's something I have to warn people about when they're like, hey, let's stop and grab fast food. I'm like, okay, but just know it's going to look a little weird when I'm eating it.
And that's neat because McDonald's, I love their Big Mac.
Yep.
And talking about fries, when I want fries for lunch, I don't go anywhere else but McDonald's.
Yeah, they have the best fries.
I love their fries.
They're so good.
Yes.
Every once in a while I'd get lucky because we didn't have any Burger Kings around, but every once in a while, if I got sent out of town, there was one area that we covered that had a Burger King. And so I always made a point to go there because I don't get it that often. They have really good chicken nuggets, which I feel like I'm probably going to get some flack for because everyone hates their chicken nuggets, but I think they're awesome. Yeah. They're so good.
Yeah, that's why Chick-fil-A is there for me, for their chicken nuggets.
Yeah. Yep. Chick-fil-A is good. We didn't have any around me. And then a lot of times, too, is Cumberland Farms. We have a lot of Cumberland Farms, like a gas station around here. Okay. And they have a whole section that has preheated pizza and a little hot bar that had chicken tenders or, whatever, little sandwiches. And it was funny because every morning you'd go in there and lined all across the parking lot, if you got there around 8 o'clock, was just service vans. And everybody was going in and getting their coffee and their, roller sausages and all that stuff. So I used to go there quite a bit too. But that was more for snacks. Okay. To get the snacks so that in between jobs I could, eat something.
Yeah, and in today's world, you've got your Wawas.
Yep.
Okay, you've got your Speedways. Mm-hmm. And then you've got your Buc-ee's. Yep. I mean, you've got this high top places where you can go in and get a good meal.
Yeah.
But again, time is of the essence. Technicians out in the field rarely get 30 minutes for lunch.
Yeah. How often did you pack your lunch?
Typically every day because I couldn't afford it.
Yeah, I know.
Couldn't afford it. It was a treat. Maybe on payday, I would go and find me a Burger King.
Yep. Yeah.
But back in the day, I couldn't afford it. So my packed lunch was sliced ham
Okay.
and American cheese on white bread 4 days a week.
Yep. I actually have that in the fridge in here right now, just in case, like in a pinch,
Oh, yeah.
You try to meal prep to save some money, and we're spoiled here. We get lunch catered all the time.
Right.
But on those days that we don't, I don't like to order out, so I'll have sandwich stuff here all the time.
And ordering out is so expensive anymore.
I know.
Oh, my God. And then the stuff you get is not even good.
No, not anything better than you can make at home.
Yeah, absolutely.
Yep. So welcome to the METUS Tech Show. My name is Bryn Raptor. I'm here with Juan Cardona.
Hola.
And today we're going to talk about the 1102 error code. So we're going to continue on this path of kind of talking about the different error codes, some of the more common ones, essentially what they mean, and then we'll start to break down what we should be checking. So Juan, what does the 1102 error code mean?
So the 1102, the error code definition, according to the service manual, is a discharge temperature fault.
Okay.
And to boil that down to the actual numbers is when the discharge temperature at the compressor reaches 248 degrees.
Okay.
That's when the system looks at it and acknowledges that there's a problem. And then it will shut the system down for 3 minutes, and then it will bring it back up again for 3 trials, hoping for the problem to go away. If that temperature is seen within 5 minutes in those 3 trials, then the system puts it on a lockout, and it displays the 1102.
Okay. So when we're talking about discharge temperature fault, I mean, if people listen to our previous episodes, they'll know. But for those who haven't, TH4 is our thermistor that's reading that compressor discharge temperature. And yeah, we're looking for anything above 248 degrees. Every 3 minutes, it'll restart. If it sees that temperature rise again within that 5 minutes, it's going to go off again. You get 3 tries, then it's going to go off on the 1102. But what happens if, let's say 10 minutes goes by?
Yeah, it's just restarts all over again.
Yeah.
It doesn't, it has to be seen within the 5 minutes.
Yeah.
Because anything beyond the 5 minute, it restarts over again.
Right. So it's still going to shut down.
Yes.
But we're restarting those 3 trials.
Correct.
So it's going to restart that process of checking.
Yes.
Okay, cool. So when it comes to that 248 degree mark, typically we talk about in our class the happy place for TH4 or our compressor discharge is between 160 to 200 degrees.
That is it.
And that's in both heating and cooling. We're always wanting to coast around that temperature range. So when we get up to 248 degrees, it indicates something's not right. Right, we have too much hot gas, or the hot gas is too hot.
Yes.
So what are some things that can cause that?
Well, definitely low charge,
Right,
or a leak. And one way to confirm that is I teach in some of my classes about the discharge superheat, where I take TC or TH4 minus TC, and it gives me the discharge superheat, which the wide range is 20 to 90 degrees.
Okay.
But the sweet spot should be between 40 and 70.
Okay.
Discharge superheat. But typically that's the best way to check and see if the system is low on refrigerant charge.
Yeah.
Or even if there's a leak.
That's actually really interesting because I've always wondered that. And with the newest updates on Maintenance Tool, they made that box for you now, and they're doing that calculation, which is awesome.
Yes.
However, without knowing roughly what it should be, it's kind of just a number, you know?
It is.
So it's good to know because I actually wasn't sure. Usually I see it in that like 48 to 50-ish range. But it's good to know that 40 to 70.
So if I may, I'm going to repeat the range again. Yep. The wide range is 20 to 90. So if it's 20, it's too low, meaning an overcharge. If it's 90, meaning too high, it's an undercharge. So in a range, the sweet spot is always the center, which is going to be between 40 and 70.
Okay. Yeah, that makes sense. And that's just a calculation of TH4, compressor discharge, minus TC, which we've talked about is just a saturation point of our high side
temperature.
Pressure. Yeah.
That's it.
So we're just taking, essentially what our saturation point is, how many degrees above that are we? That's our superheat.
Right.
Standard basic superheat calculation. But the software does it for us now, which is nice.
And typically that's a low charge. It can happen in two situations. Mm-hmm. One, the system was never charged properly, or there's definite leak.
Right.
So, and that's when you have to pressurize it, recover, pressurize it, and all that.
Yeah, you actually make a really good point. When this 1102 occurs with that particular piece of equipment, kind of matters, right? If you have a unit that's been installed for 2 months and you're getting that 1102, or maybe a week and you're getting that 1102, could be a symptom of a low charge. It wasn't charged per DSB off the install.
Yep.
But if you get an 1102 and the unit's been installed for 5 years, you might have had some sort of deterioration in the piping, or some sort of fitting gets knocked loose, whatever the case may be. You may have something else to look at when it comes to that charge issue. Is it a leak, or is it just or developed leak, or improper install?
Yeah, and let's not take for granted. There's some technicians out there that the first thing they do when they approach an outdoor unit is connect a set of gauges.
Yeah, that's
so
true.
You may not be dealing with a leak, but definitely low charge.
Right.
Because every time you connect the gauges, you're going to be removing some refrigerant.
Yep.
And gauges are not needed in our city multi equipment because we've got pressure sensors or pressure transducers that through maintenance tool, we can read pressures.
Yeah. Yep. I talk about that a lot, which is, you really should only be hooking up gauges to recover a charge. We can get all the other information we need.
Or to confirm if the pressure sensor is working properly.
Sure. Yep. So that's not the only thing that can cause an 1102. The biggest thing that can cause 1102 that doesn't relate to an undercharge or leak situation is a restriction.
Yes.
Right. So we kind of talked about it a couple of weeks ago in a podcast, what a restriction looks like. You'll get this high 63 HS1 or high pressure, a low 63 LS or low pressure, and then a high TH4. And that's because our compressor is starving for refrigerant. So whether we're starving for refrigerant because of an undercharge or a restriction, it can start to drive that temperature up and cause us 1102.
Yep.
So what are some of the most common components that would cause that restriction in our system?
Well, first, let's talk about LEVs, linear expansion valves. So we've got LEV3 at the branch controller that is responsible for superheat at the branch controller. So if that valve is failing, it's not going to allow enough refrigerant to get back to the outdoor unit, hence a high TH4, a high discharge temperature.
Yeah.
Solenoid valves at the branch controller could be stuck closed.
Yep.
Again, not allowing refrigerant through. The LEV 3s, LEV 2s at the outdoor unit, at the outlet of the condenser.
Yeah, that would be a big one.
Yes.
Yep, you'd notice that pretty quick too.
Especially in the heating mode.
Yep.
Because in the heating mode, we reverse the cycle, so therefore we don't have enough cool gas to get back to the compressor.
Yeah.
And as well the reversing valve.
Yep.
So,
yeah, and you also have like in heating mode, LEV4 does some metering.
Yes.
And that could cause another situation where you could have an 1102 come up only once you switch over to heating, because LEV4 is closed when we're in cooling only, cooling main. And then we switch over to heat, and now LEV4 is flashing, right? It's metering subcooled liquid. So that's when you might see that restriction. And so it's kind of a smart idea if you see this 1102 is maybe try both modes.
Yes.
See if it's happening in both modes. It might help narrow
That's
down
a good point.
Where that failure is. Where are we getting that restriction from? It's, you can usually see it in maintenance tool, especially if you get used to looking at it, but it could also be mode dependent. So wouldn't hurt to check both.
An LEV4 is found at the branch controller.
Yep.
And not all branch controllers have an LEV4.
Right.
So you gotta look at the piping diagram to make sure whether it does or not.
Yeah. And then obviously all of our indoor coils have LEVs too.
Yep.
So if you start to have failures, and we talked about this, but you would be surprised if one indoor coil LEV either fails wide open or fails closed, how it'll affect the refrigerant flow through that entire system.
Yep.
We talked about like a bypass and a single indoor coil with an LEV that fails open. You'll see a bypass on maintenance tool. You'll see this low TH4 condition. It won't be able to build as much head pressure just from a single LEV being open. So don't count that stuff out either.
Absolutely.
And when it comes to LEVs and solenoid valves, maintenance tool is not going to give you all the information of a failed LEV or a failed solenoid valve because they're assumed positions.
Yes, it's only going to tell you what the command to that component is.
Yes.
It's on the solenoid valves, it's only going to tell you whether it's energized or not.
Right.
It's not going to know whether it's actually open or closed.
Yeah. So then what do we have to do? How do we test it?
You're going to have to take pipe temperatures.
Mm-hmm. Yep. You could definitely take pipe temperatures.
Or check the coils.
Yep.
On the LEVs or the solenoid valves to make sure that they're good, in good condition.
Yeah. Yep. You're at that point where, you might see a general location of where that restriction's happening, and you look and you say, well, my solenoid valve's energized, so I shouldn't be having this restriction. Well, let's take our meter out, unplug, ohm it out. All of our service manuals tell you how to ohm out all of our LEVs and solenoid valves, so we got to utilize the resource and see if it's failed.
Right. And regarding our branch controllers, all of the solenoid valves in there are energized opened. So they're normally closed.
Right.
So you've got to make sure that you've got voltage to that coil, which is 208 or 230 volts AC. So once you confirm that, then you have to go further. Is it actually open or closed? And that's when you take temperature in, temperature out to see what that temperature differential is.
Yeah. Yep. That's a good point. You don't want to skip any steps.
Right.
Make sure it's getting the voltage if it's supposed to, or not getting the voltage, because you don't want to go and replace a solenoid valve and find out it was a board not putting out the voltage.
Yeah. And you know what it is. A lot of us think it's always the board.
Yep. Yeah. We get both, right?
Just
Order
like
both.
on the conventional systems, it's always the TXP.
Yep, exactly. So along the lines of things that can cause restrictions, just having a closed ball valve could
Absolutely.
be a restriction.
Absolutely. And that happens most on installation, on startup.
Mm-hmm. Yep.
Technicians forget to open both valves. I don't understand how that can happen, but, we have testimony from our tech support folks that actually it does happen.
Oh, yeah. And not even just your, your main service valves at the outdoor unit, but think about your branch controller. You could have up to 16 units hooked to a branch controller, and you leave a ball valve or two closed, but it's part of the MNet. It gets powered on. It makes a call for cooling or heating, and it hits that wall of the ball valve off of our branch controller. And there's another possible, location for a restriction, and you'll start to drive up TH4.
Right. And that's, you got to look at all possibilities because that isolation valve, again, you're talking about on a 16-port box, you're talking about 32 valves.
Yeah. Yep.
Adds up. Because you've got one for the liquid and one for the vapor line.
Yep.
And you got to check them all out.
Yes, absolutely. And then some other things to check, port address setting. So
Yes.
believe it or not, even an address setting error can cause a high TH4. Now, how are those two things correlated?
I mean, the port assignment is very important because the port needs to be connected to the right indoor unit, because if you have crossed piping or the port setting is not properly set, it's not going to be sending the refrigerant to the indoor unit.
Right.
So again, it's going to create havoc in the system, and the system is going to see it, and it may reflect with an 1102 with a high discharge temperature.
Yeah. So like the example could be, let's say you did get a 16 port branch box, but you're only using 12 of those ports.
Yeah.
And you accidentally on your 12th port assigned the port 14. And so now it's trying to send refrigerant to a port that's either valved off or capped.
Yeah.
And it's going to act the same as if you had a closed ball valve, right? It's going to create a restriction, which is going to cause us to pump down and start to raise that TH4 temperature. So even a port address error can cause that TH4 to elevate.
And that's one of the things you don't think about.
No.
Because you think about refrigerant.
Yep.
Refrigerant. And then, I mean, just as simple as a port assignment.
Yeah. And that's one of those things too. And like we mentioned, it depends on when this comes in, right? The unit's only been running for an hour or two and you get an 1102. I'm going to start thinking, okay, what valve did I leave closed?
Exactly.
Are my service valves open? Are my ball valves all open? Is everything addressed properly? But if this happens, maybe 2-3 years down the road, maybe then I'll start to consider, is this a refrigerant issue?
Right.
And we have plenty of ways to determine if it's refrigerant versus, an actual restriction for another reason.
Yeah.
So,
and temperature readings don't lie.
no, except.
Exactly.
So the only other thing that, I'd recommend checking is the thermistor itself,
Yes.
right? Especially if you hook up maintenance tool and you see something like some temperature range that just seems very abnormal. You might see just like negative 99.9 or some sort of high number, 350, 500 degrees. You could have an issue with your thermistor itself.
Absolutely.
So it's not a bad idea at that point to check that thermistor.
Yes. And one more component, let's not forget about the outdoor fan.
Right.
Because the outdoor fan in the middle of summer, let's say it's 95 degrees outside, that fan motor should ramp up.
Mm-hmm.
But let's say if something is keeping it from doing so, it's going to create a temperature issue.
Yeah.
Or even not running at all.
Right. Because now you're not even going to be doing any condensing or not enough condensing anyway.
Right.
You're going to have hot gas through the whole system.
So both your TC and your TC and TH4 are going to go up.
Yeah. Yeah, that's a good point. Yeah, if you're not rejecting that heat anywhere, you're going to have hot gas throughout that system. Probably going to be pulling it back at some point, and that TH4 is going to continue to creep up. And then when it comes to that thermistor TH4, obviously in our service manual, you can find the chart for ohming that out. So always utilize that resource. But also, the board has to put out some voltage.
Yes.
And I do mention that a lot because you could have a bad board that doesn't put out the proper voltage, and that's why you're not seeing an accurate reading on maintenance tool. And, you ohm out that TH4, put it in ambient temperature. They say the perfect thing to do is put it in ice water, but I don't know about you. When I was in a van, I never had a cup of ice water.
I didn't either. I would always ask the owner or the client, or just go on ambient temperature.
Yeah.
And that's what I always did.
Yep. I used to make sure it was in the shade.
Yes.
At ambient temperature, take it off of the pipe, put it in the shade, and then ohm it out. Give it a couple minutes, obviously. But that's how I would do it because I very rarely had a cup of ice water on hand. But if it's ohming
regarding
out,
the voltage, and that's a great point because sometimes you may get a thermistor fault.
Mm-hmm.
You check the thermistor, but the thermistor checks good.
right?
How is that possible? Well, that's when you go to the pins on the board to make sure you've got that voltage going to that thermistor.
Yeah. And that's typically a low voltage DC signal. Typically I see 5 volts DC. You might see a little less, but typically it's about 5 volts DC. It works just like your meter.
Yes.
Right? Your meter, when you put your meter into ohms to measure resistance, it's putting out a small amount of DC voltage to be able to pick up the resistance.
Yep.
So works the same off of our board. If you weren't to have any voltage, then it's not the thermistor. We're replacing the board.
Yep.
All right. Do you think there's anything else?
No, I think that's pretty much it. We've covered just about all that could give you that 1102 error code.
Yeah. So just keep in mind that when you see these things like compressor discharge, temperature fault, things like that, you got to understand this is a pretty complex machine. There's a lot of moving parts. There's a lot that goes into it.
Yes.
And when it's picking up these codes, it's not necessarily exactly how it sounds.
Exactly.
Right? So it could be failed components. It could be something related to addressing. So don't go chasing refrigerant problems. That's kind of the last step, right?
Yep.
Try to figure out what's going on first. Make sure that all the bases are covered before you go jumping into
Always cover your
refrigerant.
bases first.
Yep.
Always.
Yep.
Cool. All right. That's pretty good.
Yeah.
So where are we having lunch today?
So there's this place, Nan's Kitchen. They make good chicken sandwiches.
I've
You
heard
like
about that
Chick-fil-A?
place. Yes.
This place has wicked good chicken sandwiches.
Nan's Chicken.
N-A-N. Yep, Nan's Kitchen. And they make like other stuff too, like little quinoa bowls and stuff. But I'm in it for the hot honey chicken sandwich.
Ooh.
Yeah, it's good. It's good. I've had it a couple of times.
We're going to have to try that.
Yeah.
Do they have a drive-through?
I think so.
Okay.
You can
that's
order
even
online.
Quicker.
Yeah. Well, not very quick.
Well, no.
Here's the thing.
That
And-
sandwich is not going to be a quick
I was
sandwich.
gonna say it's actually probably a good thing because it's wicked fresh. Like it's one of those types
Yes,
of restaurants
it's
where they
not
make
pre-made.
everything. Yeah, make everything from scratch. I mean, when I had it, it tasted hand breaded and it was delicious. But I think I called at like 11:30, and by the time I got there at noon, I had to wait 15 minutes
for it.
They were pretty busy. But it's a good sign that they're probably making it fresh, which
That's
is nice.
awesome.
But
That's awesome.
yeah.
All right, Bryn, I think this was good.
Yeah. We'll see you on the next one.
All right, adios.